In this video, we're going to be talking about surface area of a prism, also known as the net area of a prism. What is a prism? Well, a prism is a 3D figure. It's going to have congruent bases, or bases that are the exact same, and it's going to have sides that are parallelograms. And so we'll talk about what each of those pieces are. Bases are identified by giving the figure its shape. So this looks like a triangular prism. That must mean that the triangles are the bases. And so it has two of them, and they're the exact same size. Prisms do not necessarily have to be sitting on their bases, so the bases are not necessarily the top and bottom shapes, although they could be. We'll talk more about that with the rectangular prism, but often the triangular prism is not sitting on the triangles, so be careful there. Faces are how we describe each of the two-dimensional sides here, so the two-dimensional areas, and there are 5 shapes total here. So we have the 2 base shapes, the triangles, and then we also have 3 rectangles. So those are our parallelogram sides. So that adds up to 5 faces. There will be a difference between the base sides and the non-base sides. We'll talk about that in a minute. Edges are just the corners here where the planes meet, and if you want to count them up, there are 9 of them. And prisms get their name from their base shapes. So if this is a shape that looks triangular, we're going to say the triangles are the bases, and we call it a triangular prism. If the triangle is a right triangle, we call it a right triangular prism. It's a tongue twister. All right, there are 2 types of surface areas. Total surface area would be the area of every face or every side of this shape. Lateral area is just the areas without the bases. So if I find the area of my rectangles here, those would be my lateral areas. All of the area without including the bases. Total surface area will include the bases. So when we find the lateral area, it is true that we can find the area of each of these two-dimensional shapes. So if I find the area of this rectangle in the back left here, and the area of the rectangle on the bottom, and the area of the rectangle going down the top here, and add all those together, that would be the lateral area. But there is a shortcut, and we'll talk about why we're allowed to take this shortcut. But here it is. If we just find the perimeter of the base shape, so if I find the perimeter of this triangle, and I multiply that by the height of the prism, remember that the height is going to be perpendicular to the base, so this is actually the height of the prism, then that is also the lateral area. It's a nice little shortcut. The total surface area would just be that lateral area plus our 2 base areas. So let's do an example. Let's figure out why that shortcut is possible. Let's try and go the long way here. We want to find the lateral area of this right triangular prism here. So if I find the area of this back rectangle, that would be a 3 by 2.5 is that length in the back. If I want to find the bottom rectangular area, that would be 4 times 2.5. And then if I want to find the area of the top rectangle, that would be a 5 times 2.5. Now where did we get this 5, this length, slanted length right here? Well, we can use Pythagorean theorem to find that missing side of the triangle. Or we can recognize our special triangles. There's a 3-4-5 ratio or a 5-12-13. So this is in the 3-4-5 ratio. So you can assume that that length is 5, or you can use Pythagorean theorem to prove it. 3 squared plus 4 squared, and then square root that, and that should give you 5. So the top area, 5 times 2.5. Okay, so we have these 3 areas that we could find and add them together, but notice that they all have 2.5 as a common factor. So if we factor out 2.5, what's left over is the perimeter of the base, or the perimeter of the triangle, 3 plus 4 plus 5. And 2.5 is the height of the prism. So that's why we're allowed to take that shortcut to find lateral area. It's just the base perimeter times the prism height. but you can always go the long way if you wish. So the lateral area, when we put it all together, is 30 square units, whatever the units are. So that's our lateral area. To find the total surface area, we just got to find our two base areas, or one of the base areas, and double it because our bases are congruent. So the area of this triangle is 3 times 4 divided by 2, base times height divided by 2. So the area of the triangle is 6, and there are 2 of them. So if we double that area, there's our 2 base areas. So our 2 base areas add up to 12. Take our lateral area plus our 2 base areas, put it together, and our total surface area is 42 square units. When dealing with triangles, since there are 2 bases and in our area formula we're dividing by 2, you can kind of take a shortcut if you can get used to it or know why you're doing it. You can just find the area of one triangle, 3 times 4 divided by 2. And instead of dividing by 2 to multiply by 2 to get 2 base areas, just do the base times the height. And that will give you the area of both of those triangles put together. But just be careful and know exactly why you're taking that shortcut. A rectangular prism is slightly different. It's a little less tricky in that we're just going to say that the top and bottom are always the base. So if we find our base perimeter, that would be 8 plus 3 times 2, or you could do 8 plus 3 plus 8 plus 3. So the base perimeter is 2 times 11, or 22. If you multiply that by the prism height, which is 5, then that'll be our lateral area. So 22 times 5, or 2 times 11 times 5, is 110 square units. All we have to do to find the total area is add in the areas of the top and bottom shapes. Well, the area of the bottom is 8 times 3, which is 24. Since there's 2 of them that are the same size, we could double that. So 2 base areas are 48. Combine that with our lateral area to get the total area, and we get 158 square units. So there's the surface area of right prisms, triangular and rectangular specifically.